to this lesson of a study of linear algebra, and this happens to be our first video. So in this lesson, what I'm going to do is going to talk about some basic concept in solving linear equations, particularly in systems of linear equations. All right. So yeah, if I have a system of linear equations, what does it mean? So if you have a finite set of linear equations in variables, maybe x1, x2, xn, it's called a system of linear equation. And what we mean is you can count the equations, right? This is the meaning of the finite number of equations. I can call this maybe equation 1. This is another equation 2. This is the third one, right? So we can count them, and then we call all of these systems as systems of linear equations. All right. Okay. So now the things you're supposed to know is that every system of linear equation has either no solution. Okay, so you can have a system of linear equation that has no solution, or you can get exactly one solution, and sometimes you have infinitely many solutions. Okay, so I'm assuming that I have these two equations, a1x plus b1y here is equal to c1, and then a2x plus b2y equal to c2. Here the variables we are dealing with is not x1, x2, and x3 anymore, but we are dealing with the variables x and y. And we are looking for these variables such that when you put some particular constant a1, b1 in front of these and you sum them, you get c1, and when you put a2, b2 in front of them, you're gonna get c2. And if you graph these lines, we have three possibilities that can happen. It's either one, maybe if I call this one line 1 and I call this line 2, it can happen that maybe this is line 1 and this is line 2. They are parallel to each other. And if you have two lines that are parallel to each other, they don't meet. And I mean, ideally, the solution to this system will be you're looking for all the points that they meet. At what point do these equations meet, or maybe at what point do you have same values as x and y for this equation and same values for x and y for this equation? So it's like, at what point do they intersect? Okay, so if it happens in the first scenario, then you don't have a solution. It can also happen that they meet at only one point, exactly one point, and that's when you have one solution. And when it happens that one is lying on top of the other, okay, so here you see that the blue is lying on top of the white, so they can actually meet at infinitely many points. That is the visualization of the word infinitely many solution, and one is only one solution and the rest. Okay, now we call something augmented matrix. Okay, so we're gonna use this idea to solve almost every system of linear equation that we'll get. And this approach is the one that tells us that indeed we have a solution, one solution, or there is infinitely many solutions. So if you put all the numbers in front of every variable in a matrix form, the matrix we obtain is called an augmented matrix. I mean, this statement, maybe I didn't write it well, but what I mean by this is you open a matrix like this. Okay, so the way you do is you count how many equations I have. 1, 2, 3 equations, so I count them. Okay, and what I do is I look at the first variable, which is x1 in the first equation, and put the number in front of x1 into the first equation. We have 1 in front of it. Then you go to x2, and in that case we have 1 in front of x2, and we'll have 2 in front of x3. Then you go to the next row, so you write this whole thing as one row. Come on, write the next one as a second row. Okay, you write this one as a second row, so I'm going to have 2, 4, -3, and then the third row is going to take these values, and that's going to be 3, 6, -5. Now after everything, what you're going to do is try to put these guys at their respective rows. So the 9 corresponds to this row, the 1 corresponds to that row, and this corresponds to this row as well. Let me use the white. So that is exactly what we mean by the augmented matrix. And in this case, this is what we have. Then you put So this idea is coming from this case that if I multiply this, if you've done matrix multiplication, which I'll treat in this course, basically not that. All right, so what I wanted to use to prove this is actually something else. I'll do that when I'm doing matrix multiplication, but this is what we call augmented matrix, and some people prefer to separate the main variable side. I mean, these are the side that we have our x1, x2, and x3, and this is what we have at the right side of each equation. So you try to separate it and then perform whatever operation they want to perform on it. All right. Now let's go to me giving you a problem and try to see if you can write augmented matrix. So if I have maybe an augmented matrix or maybe an equation that has these a1 x1 plus a2 x2 plus a3 x3, where a and then a is constant, b is also constant, and you have a2 x2, or maybe sorry, I'm going to call this as c1 x1 c2 x2 is equal to b2. If I want to write augmented matrix for these two equations, then that matrix is going to be a1 a2 a3 and then c1 c2 c3, and then I write these values at their respective. If you want to separate it, like I said, then you do it this way. Okay, so basically that is what I can say in this introductory video, that we have systems of equations. You want to solve this is one equation, this is another equation. So we want to find a value, that values of x1 x2 x3 that will satisfy all these equations. So the values you get, maybe x1 x2 x3, when you put them back in this whole equation, it satisfies each one of them. So if I put x1 x2 x3 in equation 1 and sum this side, I will get b1. If I put it in equation 2 and sum that, I get b2 as well. Alright, so that is the whole basic idea about introduction to systems of equation. In our next class or in our next discussion, I'm going to take examples and work you through how to solve these kind of problems. Okay. Alright, so see you.